Good morning, everyone. Hope you are doing well. We are going to learn how to do multicollinearity test or perfect correlation test. Okay, when we have to run a model, we need to do that and see if there is a presence of multicollinearity among our independent variables before to proceed. If you have things like this, we have a problem of presence of multicollinearity. We can just decide to correct it before to go, because it's things which can affect our result. Then among those diagonals we can do before to run our model, we have this one we are calling multicollinearity test. And now, okay, as we can see, I have already some data inside, and we can try to do that. Okay, then to do multicollinearity test, as I was saying, the command is pwcore. And now you can just drop your variables, those different variables where you want to check the presence of multicollinearity or not. Then after pwcore, I'm just using open, high, low, close, and volume. And what I want just to remind is, when you are running a model, you are checking the presence of multicollinearity only among independent variables. Okay, then let us consider those are 1, 2, 3, 5 variables and do that. Okay, let us add this one, which will bring the p-value, and which can help us to know which coefficients are significant in terms of correlation. Okay, then when we validate, we can have something like this. Okay, what is happening here? What's the interpretation? As we can see, wherever we have 1, 1 is the intersection of the same variable. Open, open, we have 1. High, high, we have 1, meaning that the correlation is very high. Okay, we have to now say that the interval of correlation should be between -1 and 1. When a value is closer to 1, we have a correlation, a big correlation, a strong correlation. And when the variable is closer to -1, we have a strong correlation which is negative. It's what is happening. And as we can see around here, when we are taking this variable high and open, the coefficients of correlation is 0.99, which is very, very closer to 1. We have a strong correlation here. And as you can see, we have this p-value which is coming also and now confirming that the correlation is very strong. When the p-value is less than 5%, when the p-value is less than, it's just telling us that the value or the coefficients of relationship or the coefficients of correlation is significant. Okay, it's the same thing happening with low and open. Okay, here we have a strong correlation which is also positive. As you can see, the sign of the coefficient positive. When we are taking the value like volume and open, we can see that also the significance, the p-value is significant, saying that, okay, the correlation is significant, but here the correlation is negative. As you can just see, the negative sign is what is happening. Now, when we have things like this, we have a strong correlation among different variables. We can decide now. Usually, what you are doing is just drop 1, because it will affect your result if you are not correcting this problem. Yeah, that is. And wherever also you want to just to see the correlation among variables. Yeah, maybe what we are just doing is not to check on multicollinearity, but you want just to see the correlation existing between 2 variables. It's the same command we are using. We can just come, let's say that we want just to see the correlation between the variable open and high. What we have just to do is just to come and do this, and now we can validate. And can you see the relationship or the correlation between open and high is 0.99, very closer to 1, a strong relationship here. Now, say that what is, when we are talking about correlation in another way, what is happening? Saying that when we have all those variables like open and high somewhere, when high will be increasing, will increase, open also will be increasing. The relationship is positive and very strong. Okay. I hope that this video will help you in your research when you are taking on multicollinear presence or not of the multicollinearity, and when also you are taking to see the coefficients of correlation among variables. Have a good day.